Well, hi everyone, and welcome to today's Homer Energy's educational webinar series. I'm Marilyn Walker, the Chief Operating Officer here at Homer Energy, and I'll be your host today. So today's webinar is a tour, a demonstration of certain parts of Homer Pro, the new version of Homer that we released in October of 2014. We're going to begin with a brief introduction from Dr. Peter Lilienthal. He's our Chief Executive Officer and creator of Homer. He's going to introduce the company and its history. Then we'll hear from Homer Energy engineer John Glassmeyer. He's going to demonstrate the major features of the product, talk a little bit about some of the differences of it from Homer 2, and then we're going to hear from John Auerbach, who's going to preview some of the highlights of version 3.3 due for release in about a month. And I think we're going to focus a little bit there on some of the new things we're doing with Unreliable Grid. And if we don't get to all the questions, we do have an online forum where you can continue the discussion. And I'm also going to give you some links at the end of how to get questions answered and support. So with that, I'm going to hand the reins over to Peter Lilienthal. Okay,
well, thank
Peter.
Thank you, Marilyn, and thank you all for attending. As Marilyn mentioned, this is our monthly webinar series. We're focusing for this one on our own software, and I always like to give a little history of Homer and how we got to where we are. It developed originally at the National Renewable Energy Laboratory, starting with their Village Power program back in 1992. It's been around for a long time. Later in around 2000, we expanded it to look at larger systems. So now we don't just look at village power systems. We look at island systems up to 100 megawatts or larger. In 2009, we spun off Homer Energy as a separate private company. Original developers, including myself, formed it, and we're up to 12 people now. But more importantly, we have 120,000 users in 193 countries. So the pie chart in the lower left gives a sense of the geographic spread, which is really quite global. And in fact, a lot of the US and Western European users are actually looking at projects in the developing world. The big news has been our updated version, Homer Pro, which we released back in October. We're going to talk a lot more about that, but that was our biggest change in the last couple of years. And what we're doing is having quarterly updates. So every 3 months we come up with a new version. We'll be on our third of those quarterly updates next month. John Auerbach's going to talk about that. The graph on the right is kind of specific to our company, but it really, I think, parallels the growth of interest in microgrids in general, which has really taken off in the last couple of years, excuse me. So I'd like to talk about how we view Homer fitting into the wider world, and we view it as a communication tool to bridge different worlds. So on the one hand, we talk a lot with renewable advocates who are pushing for the clean energy, new clean energy economy, etc. But we also talk a lot with utility operators, people who've been running diesel generators or other, traditional technologies for decades, and these are really people that live in different worlds with different languages and different cultures, etc. But to make progress, they need to talk together. They need to have a common language. And the same is true for the power engineers who have their own tools, very sophisticated power engineering tools, and the finance world, which has a lot of spreadsheets. They have their tools, very, very different kinds of tools, and they're not talking the same language because and a lot of it has to do with what tool they're using. So we've created Homer to bridge those gaps, to be a tool that all of these different people can use and have a sort of a common language between them. So that's our goal, and we'd always like to hear from our users whether they think we're achieving that goal or how we might be able to achieve that goal better. I also like to talk about the markets that we work in, and because they're very diverse, both geographically but also in terms of the application. And so I think of it in four distinct groups. The one we're probably most active in are these islanded grids or remote grids, places where you have a real utility system operating now, but it's probably mostly diesel. And renewables are very cost effective against diesel, even with today's oil prices, because of today's PV prices, mostly, although wind is still better if you have the great resource, etc. That's one market. The original market was the energy access market, which is 1.3 billion people where there's no infrastructure at all. And microgrids based on renewables is the most promising solution for them. There's a really big infrastructure issue, both it goes, or institutional issue. It goes beyond the technology of accessing that market. But we're real active in that market, and microgrids are really the most promising technology to provide 24-hour AC grid quality power. The interesting growing market now, we call it resilience, is here, especially here in the U.S., especially in the Northeast, where they've been battered by some storms and had power outages that lasted a week or more. The military can't tolerate that kind of outage, but not just the military, any critical infrastructure emergency service. And what we've learned over the last several years is that there's a lot more applications or more facilities that would fall into this category of critical infrastructure than you might normally think. So they're very interested in microgrids that can stand on their own for weeks at a time in an emergency, but are grid connected most of the time. So it's actually kind of different, but it shares some important similarities. A really interesting and large market, though, now that solar has become so cost effective and batteries are getting there, is throughout the entire world, wherever the grid is unreliable and people are relying on backup generators frequently or a lot, burning a lot of fuel, incurring a lot of maintenance costs, incurring a lot of hassles with just dealing with diesel generators and their noise, etc. They're great if you don't have to use them very much, but if you're using them a lot, suddenly a renewable-based microgrid starts to look really attractive. So that's a potentially huge market that I think is kind of overlooked for the most part. So those are the markets that we work in. And before I turn this over to John Glassmeyer to show you our new HOMER Pro, I just want to give a little shout out to our industry partners.
Unmuted.
Because we have such a large user base around the world, we work with industries that want to access that market and all of our users, and so I always want to give them a little credit for working with us, and we're always looking for new industry partners, so let us know if you're interested in that. But with that, I'm going to pass this on to John Glassmeyer, who's going to give you a tour of HOMER Pro and its new capabilities.
Great, thanks, Peter. Okay, John, you are up.
Great, thank you, Peter and Marilyn. So as Peter mentioned, I'll be telling you a bit more about the features of the HOMER Pro software. So some of you may already know this, but HOMER Pro is a tool for rapid assessment of least cost solutions for clean, reliable power. The HOMER software compares thousands of possible combinations of solar, wind, storage, load management, and conventional generators, including combined heat and power systems, as either standalone or grid-connected systems in basically only a few minutes. It allows users to sort feasible systems by dozens of variables, and HOMER's optimization can consider interest rates, tariffs, sellback rates, emission goals, renewable resources, fuel prices, renewable goals, equipment prices, performances, and just a lot of options. The operational details of each possible system can be examined down to the minute or hour. So as you can see here on this slide, here's a schematic that shows you a spread of conventional resources, such as diesel gensets, with renewable resources like PV and wind, along with storage like flywheels or batteries, and some load management. The basic version of HOMER Pro contains most of the features that you'll need for your typical analysis. It contains all the features you need to analyze a microgrid or a hybrid renewable power system with wind, diesel, or say solar diesel and some storage, as well as a wide suite of analytical and visualization tools that are included in all of our products. In addition to the base product, we have some advanced modules. They're listed out here. Those are really pulled off so that we can specifically develop those, and you can have access to targeted technologies that meet exactly your needs. So HOMER Pro builds upon our previous product, HOMER 2. HOMER Pro offers a range of new components as well as enhancements to some of the components from HOMER 2. HOMER Pro can model more PV arrays and more generators. It provides new maintenance and modeling tools. We've also expanded the use of component libraries. Whereas HOMER 2 only provided libraries for all components, we also now do components, loads, and resources. So, and we're working with manufacturers to fill out the library with as many makes and models as possible. So HOMER Pro also features new results, outputs, new data input tools. It has parallel processing for rapid analysis and enables you to develop models more quickly, in many cases up to 3 times faster. So with that brief introduction via slideshow, I'll switch over to the HOMER software itself. So some of you may be familiar with the HOMER Pro software, but here's the starting home page. And the best way to understand HOMER Pro is to see it and use it. Although all downloads of HOMER Pro come with a free 30-day trial to test out the software, I'm going to quickly demonstrate a quick simulation, optimization, and sensitivity analysis so that you can see some of the capabilities. So anytime you open HOMER Pro, you'll start at this, the home page. This is where you can fill out basic information about your project. Here we're going to be building, so Peter talked about the 4 microgrid markets. We're going to build a community mini-grid. So we're going to put that, we'll name our project here, Community Mini-Grid. We'll put in an author, so that'll be me, John Glassmeyer. And we can choose a location anywhere in the world by clicking on the map, or you can type in a location. So I decided to put our mini-grid project in Northern Africa, so in Chad. So once you've selected your location, set your basic parameters, you can add a load. So we'll come up here to the load ribbon and click on this electric number 1. And one of the things that we now offer as an enhancement from HOMER 2 is we have default load profiles. So if you look here, you can see we've got generic profiles built up for these 4 sort of basic types. For this analysis, I decided we'll do a community load. And since the nature of a lot of these communities in Northern Africa is limited seasonality, I chose no peak. You click OK. And HOMER Pro automatically creates a representative load profile for an entire year for an end use of that type. So now that we've got a load, let's design a system to meet that electrical load. To do that, you come up here to the component ribbon, and the backbone of most mini-grids worldwide, microgrids worldwide, is a diesel genset, so we'll start there. You can see that from our load profile, our peak is about 20 kilowatts. So I'm going to add in a, let's say, 50 kilowatt genset as a starting point. And I'll add in this generic genset, and then I'll modify it to meet that load. So I'm going to make this my own. So I'm going to change it from a 50 kilowatt genset to a 25 kilowatt genset. And the reason I do this is that a 50 kilowatt and 25 kilowatt genset are similar. So you'll notice that as we added this, we selected it from a library. That's a new feature in HOMER Pro. In HOMER 2, we would have had to develop all of this information and know the inputs in advance. So we've made this easier for you by providing some genset models to help you build up your model quickly. You'll also see that the library component includes cost data. So here we've, by default, started this genset with a $500 a kilowatt cost and a 3 cent per operating hour operations and maintenance cost. So let's see, we've sized it, and we're going to want to do a sensitivity analysis during this. So I'm going to go ahead and put in a sensitivity analysis on fuel price. So here down at the bottom is fuel resource, and there's the fuel price. Let's say we want to look at what if the price in our system is $1, or what if it's say a little less at 50 cents. $0.50 or a little more at $1.50 a liter. And you'll see that when we have our sensitivity inputs button here, when I click OK, it'll change to 3 for each of those 3 fuel prices we selected. You'll also see, if you just want to look around, we've got a fuel curve built into the models for heat rate and performance D-rate as you go to lower power outputs. And I want to draw your attention to this maintenance schedule. So we now have in Homer Pro the ability to schedule maintenance. So you can add in, say, an oil change, so periodic oil change, and that would occur, say, every 1,000 hours, and you might have some downtime of, say, 10 hours at a cost of, for this, say, $300. So you can do this explicit modeling of maintenance scheduling. I think for this analysis, I'm going to keep it simple. I just wanted to demonstrate that. And let's move on. So to the next component. So we've got a generator to meet our load. Let's add a battery. So we'll come back up here to our component ribbon and add a battery. We've got a whole set of batteries that you can choose from, as well as some that I've created here. Let's put in a lead acid battery. So in most of the components, we tried to have generic components included so that you can do high-level analysis for getting roughly to the right place in your design. So we'll add that battery. And you can see that this battery has a $300 per unit cost. And we'll decide to model it with no batteries, as well as, say, 50, 100, and 150, just to cover the space of options. So if you look at our schematic, when we added the battery, it brought in this DC, direct current bus, and the generator and load are on the AC bus, the alternating current bus. So in order to get energy between those, we'll need to add a converter. So we'll come up here to the component ribbon, add in a converter, and this loads up by default our generic system converter, which we've found that $300 a kilowatt's a good starting point for the cost of one of those. And we'll size this roughly to our peak. You could do more analysis there, but let's keep it simple and say a 24 kilowatt converter to meet our peak, and then a system without a converter. So let's see, we've got a generator to meet a load along with a battery and a converter. Let's add in some renewable energy. And in fact here, Homer Pro in the suggestions box is even recommending you might consider looking at renewable energy. So let's take that advice. And again, back up to the component ribbon. We'll add in a PV. You can look down. So we've got this new component here, concentrating PV. So if, that's a very specific technology that we've now got in Homer Pro that was not in Homer 2. But we're going to stick with the traditional flat plate PV. We'll add it to our model. And one thing that you can do actually is if I add another PV, you'll see that I can now add 2 PVs. And in fact, I can add up to 10 of these. We'll remove that because I think in this analysis, we're just going to do the 1 PV array. And let's size that PV array by jumps of 10 kilowatts, 10, 20, 30, 40, and 50 kilowatt arrays. And if you're familiar with Homer 2, you'll see that we've got this new feature down here, a maximum power point tracker. So you can explicitly model the cost of this maximum power point tracker. Or if you want to have your AC or your PV component to have AC output, you switch it over to AC, you'll see that maximum power point tracker becomes an inverter. So you can do a dedicated inverter. But we'll have our PV go onto the DC bus. And let's see. So we've added the PV, and we look at our advice box from Homer, and it says to add in the sun, add in a solar GHI, or global horizontal irradiance resource. So to do that, come up to the resource ribbon and click on solar GHI. So you'll see that Homer's automatically figured out our location from the project location that we specified on the home page at the start. And all we need to do is click download from the internet. And Homer will automatically download data, in this case from the National Renewable Energy Labs database. And the suggestions have gone away, but before we finalize this, let's add in some wind as well. So I'm going to come back to the component ribbon and add in a wind turbine. So we've got a whole set of wind turbines we can choose. I'm going to choose a generic 3 kilowatt wind turbine. Add it, and you'll see it shows up on our schematic with a cost of $10,000 per 3 kilowatt turbine, and we'll consider up to 5 of those, 2, 3, 4, and 5. So we're almost done. I think we're almost ready to calculate, but we still need to add a wind resource. So let's do that. Come over to the resources ribbon and look up the wind resource. And we'll put in Homer will help you to synthesize a wind resource. So I'll put in the average monthly wind resource. So we can assume that we've gotten some data and that the data says that it's 4 meters per second. Homer can use that to create an entire year's worth of wind speeds. And we'll say, what if, before we move on, let's do a what if analysis, a sensitivity analysis, by clicking this button, saying, well, what if that's not 4 meters per second, but it's 5 meters per second, or 6 meters per second, or 7 meters per second. In other words, what if the wind resource improves? So say OK, and now we've got a model, and we can click calculate, and Homer will start churning away on that. So while this calculates, I'd like to mention that, reinforce this idea that I mentioned earlier, that the speed of calculation is actually dramatically improved in Homer Pro. We're analyzing over 3,400 simulations to find the optimal system for a range of sensitivity cases. The parallel processing makes this run much faster than Homer 2, which we estimate would be about 3 times as long. And that's one of the greatest advantages of the Homer software for analyzing and evaluating these hybrid renewable power systems.
John, I'm gonna
yes.
Can I sneak a question in here?
Yeah, of course.
Yeah, we have a question. Is there any way to change any parameters for the PV component? Thought this would be a good.
Oh, that's a great question. Yes, you can customize pretty much any input in the Homer software. What we've done is provided generic starting points because we get a lot of questions from our users about, well, what should I start with? So if I go back to my design and open up the PV, I can change the lifetime, the derating factor, change any of these basic parameters down here, say the ground reflectance. There's a lot of parameters that you can control. If you want to change the inputs, we have the ability to do that. And you can do sensitivity analysis on most of those. So with that tangent, let me come back to our results. So our calculation is finished. And one of the key outputs that we do is this optimal system type graph. So what this graph shows is across the range of sensitivity values we considered. So you remember we put in 3 fuel prices, 50 cents a liter, $1 a liter, and $1.50 a liter. And across the range of wind scaled annual averages, 4 meters per second, 5, 6, and 7 meters per second, Homer calculates what type of system is optimal. So this red region here represents a generator PV system, and this green area represents a generator wind turbine PV battery system. So you can see that the fuel price has some impact on whether you choose to do a PV or a wind system, but the bigger driver is this wind speed. If you've got a good wind speed, intuitively, you would want to add wind to your system. Another key finding is that PV is actually a cost-effective contributor in the entire space that we considered. So these optimal system type graphs are a really unique output for the Homer software and something that you can get easily and quickly. So let's go back and do a little bit more tabular data. So I'm going to click on this tabular button. So if you look at this table on the top, each of these lines corresponds to each of the sensitivity cases that we developed. So for example, this top line is the sensitivity case where the fuel is 50 cents a liter and the wind speed is 4 meters per second. And if you click on that, it will load up the optimization cases. So what system is optimal at that sensitivity case and what's the ranking of systems within that. So Let's choose a nice default sensitivity case. Let's say we think that our price will be $1 and the scaled average of wind is likely to be about 6 meters per second. Click on that and you'll see that the optimization cases table updated to provide the system rankings for that sensitivity case. So one of the things, this is a new way to present this data as compared to Homer 2. We've now got these tables right next to each other, so it's easy to see that when I've selected this sensitivity case, this is my optimization results. And in addition to that, we have a lot of new tools for filtering. So if I click on, say I want to filter out systems that have a capital cost greater than, or excuse me, less, I only want systems that have a capital cost less than, say, 50,000 US dollars. Click filter, you'll see it'll filter out those results. So that's a tool for doing that, or you can clear that. You can also sort on these systems. So let's say I wanted to, instead of sorting on net present cost, I could sort on, say, initial capital or renewable fraction. These are just tools to help you look at your data. Another thing that you can do is when you're looking, if you pick out a particular system within the optimization ranking here in the optimization case table, you can double click on it and that will bring up the simulation results for that system. So here we've clicked on the lowest cost system at the top, and that brings up the simulation results window by default at the cost summary tab. The cost summary tab shows you an allocation of economics over the life of the project. So you can see that over the life of the project, I'll expect to spend about $140,000 on capital and something like $100,000 on fuel. You can look at that cash breakdown a little differently in a cash flow. You can see the year-by-year cash flow for this system. So there's a big capital outlay, and then each year you have operating maintenance costs and occasional equipment replacements. You can go to the electrical tab and see where electricity is produced. So you can see that 46% of the energy comes from PV. This is a heavily PV-loaded system, as well as where the energy is consumed and how much excess electricity your system generates. A new feature in Homer Pro is this fuel summary tab, so you can see how much fuel is used by genset, or excuse me, by generator component. And as well, we have tabs for each of the major components that give you detailed breakdown and charts for understanding how that component was used in this simulation. And of course, we have emissions results as well. Another valuable tool in the simulation results is this plot button. So under the time series, you can use these time series tools for creating graphs. One of the most useful ones is this plot button. You click on it, and here it showed up on my other window. I'll maximize that. You can look at, so this by default starts with the AC primary load loaded up for each hour of the year, and we can zoom out to a whole year. So let me do that. Zoom out to the whole year. And you can zoom in on a particular time, say here in June. If I click and drag, we'll zoom in on that time of the year, and you can overlay things such as the PV power output, or the wind turbine power output, or the generator power output. As well, any of these parameters on the right, you can display them. And you can even create a second axis to see what else is happening on a different set of axes. So here I've included the battery state of charge, so you can see how that battery is getting used. So there's a lot of other tools here that I'm just going to draw a note that these exist, and then I want to go back and show you this compare button. This is an often overlooked feature of the Homer Pro software. This compare is on the cost summary tab. Click compare, and that allows you to compare the economics. So you can take the system we selected and compare it with any other system. The one that makes typically most sense is with a diesel genset system, because that's the worldwide incumbent technology for these sorts of systems. So if we click on that, you'll see that it calculates a return on investment of 19% and a simple payback of about 5 years for the PV wind system as compared to this generator-only system. So that was a quick demonstration of how to simulate, optimize, and perform sensitivity analysis on a hybrid renewable energy power system. This one was focused on a community mini-grid, but as Peter noted at the start, we can do this analysis for any sort of hybrid renewable power system, which I believe he broke it into the 4 components. We do analysis in all of those 4 mini-grid sectors or microgrid sectors. Before I pass off to John Auerbach, I want to talk about a few other features that you might be interested in. One of them is the library management tool. So we've created a library tool to help you manage libraries for all your components. Let me minimize these because you can see that we've now got library items, as I mentioned, for components, resources, loads, as well as some of the project parameters. So you can easily create a new component within any of your components. And let's see, let's go back to our design. Let's point out some of the other components that might be of interest. We now have a thermal load controller. So a thermal load controller allows you to manage excess electrical loads and contribute to the thermal load in a combined heat and power system. This is a new feature in our combined heat and power system analysis. You may know these thermal loads also as dump loads or secondary load controllers. And we also have hydrokinetic turbines. And this is a technology that allows you to use momentum of moving water to generate electricity. In addition to those new components, and the components we covered as we went through our sample analysis, we've also improved a number of the components. A really, really important one is here under the grid. So I'm going to open this grid component and show you that you can now specify a grid outage. So if you say grid outage, you can say outage, and in this grid throughout the year you can specify an outage. Say maybe the power goes off from 1 p.m. to 5 p.m. every day. You can specify that, and Homer will optimize the system assuming that you don't have power from the grid, and that power has to be met. Your load has to be met from some other source. So with that, I'm going to pass off to John Auerbach, and thank you very much for your time.
Okay, John, you are good to go.
Okay, thank you, John. Thank you, Marilyn. Hi, everyone. I have a sneak peek of some new Homer Pro features that we're developing for the next update. These will be released around April 15th. So here I'm running a development version of Homer Pro, and this will become version 3.2 in a few weeks. The first feature I'd like to show you is on the Homer on the home page, and it's this new resources button. So first, let's set a location, let's say Boulder, Colorado. And now I can click on the resources button, and it's downloading what resources are available for my location. And I can select NREL solar data. I can also select temperature and wind data, which was not available in Homer 2. And when I click download, Homer will add these to my model. And so now if I add a wind turbine or a PV, the resource data will already be there ready to go. The next feature I'd like to talk about is one that we're pretty excited about. I can add a grid to the model, and if I select real-time rates or scheduled rates, I get a reliability tab where I can input settings to model an unreliable grid. So here I can add a mean failure frequency, a mean repair time, and I can give it a variability in the repair time. And these black lines are when the grid will not be operational. And so during these times, Homer will have to meet the load with the other components of the system. And I can also change the mean failure frequency to whatever I want to simulate a grid with more or less outages. Lastly, I'd like to show you one more exciting development in the HOMER software. We now have an API available so you can program your own custom dispatch. Companies can now write their own dispatch strategy, compile it into a DLL, and integrate that into HOMER Pro. Your alternate dispatch algorithm will show up here in the system control menu, and you can just select it from this drop-down menu to pick the regular standard dispatch or your custom algorithm. If this is something that you are interested in, contact us about customization and API integration. Thanks, Marilyn.
Okay, great, thanks. Okay, thank you to everyone. So we have great questions, and we probably aren't going to get to all of them. We will get to as many as we can. But actually, I think they're relevant to what I'm going to talk about, which is how to get support and training. So, you know, HOMER it's a big piece of software. You know, probably takes years of working with it to get really good in all of it. But we really recommend training. And we also have a support site, which is available to everyone. You know, if you're on a trial version or a paid version, support.homerenergy.com. And there's two things there that are worth knowing about. One is that a knowledge base. You can search it, and often your question has already been answered. And the other is you can submit a ticket and get an answer from our engineer. So, you know, please use that resource because, you know, we want you to understand what HOMER can do. The other is our training program, and we really highly recommend that everyone who's new to HOMER take our Introduction to HOMER course. All the information about our trainings, including how to sign up for that, are at gethomertraining.com, and we've made it really reasonable. We've tried to come up with times that work around the world. We can't fit it perfectly, but we think we have times that are, you know, daylight or at least wake hours for everyone. And then quickly, I just want to tell you that now that HOMER Pro is out, we've put together advanced courses, and we've identified 10 core subjects: advanced wind and solar, larger systems with multiple diesels, advanced loads and load management, advanced storage, high renewable penetration systems, advanced grid, thermal loads, combined heat and power, biomass and hydro, fuel cells, combustion turbines, microturbines, and hydrogen. So these are all available immediately if you want a private session, and we're looking at offering them as online classes similar to what we've done with the introductory class. So we're a small company, so what we're doing is trying to find out what courses most people would like to have available. So I really recommend you, I'm going to give you all the links that I've given in just a minute, but this is a survey we have open right now. It's also going to be in your post-webinar email. So if you're interested in these topics, please be sure to take that survey and tell us what's most important to you. Okay, so I'm going to dive into the questions now, and but I'll leave these links up so you can see them. Okay, first question, load. Could you please provide more information about how load profiles are generated? I see there's some confusion out there about these automatic loads that we have. People ask, do we consider country, latitude, income, tariff, etc. on the load profile? So how can they get a load profile that fits their situation? You guys need to make sure to unmute yourselves. Go ahead, John.
Yeah. So we basically included those default loads so that you had a place to get started. If that's not, if you need one that's specifically tailored to your situation, we also offer a synthesization module that allows you to put in a load profile that's basically minimal data to generate a realistic profile for a location. And in addition, we allow you to import hour by hour or minute by minute data so that if you have measured data, you can pull that in.
Great. And how about a maximum load? Is there a maximum load HOMER can handle?
And not really. There's no real maximum load. There is a maximum number of generators, 20 generators. We typically look at loads in the kilowatt to megawatt range. It has been used to model loads in the several hundred megawatt range. There's no upper limit really. The larger the system, the more of an overview kind of analysis that you're going to be doing as opposed to a detailed analysis. But the short answer is there's no firm upper limit.
Okay. How about what goes into the PV capital cost? So, how do I get that cost? Your cost seemed really high that you used.
Right. So the PV capital cost is going to vary regionally based on a number of factors: delivery, a local ability to install, the availability, the cost of the racking system that you're using, the location that you're trying to put it in, taxes. The installed cost is meant to be a bundle up of all of the costs it takes to get a PV array installed and connected up to your power system. So $3 a watt is appropriate for maybe some smaller systems in some parts of the world, but yeah, I've heard people quoting installed costs as low as $1.50 to $2 a watt. So it just depends. That's why we allow you to do sensitivity analysis on it.
Okay. Can I define priorities in hybrid systems when I have a combination of hydrogen and batteries?
Can I define priorities? So
yeah.
Homer by default uses an economic dispatch, and so the way it does that is it looks at, well, what's the cheapest way for me to meet my load at a particular time step? It doesn't look ahead, but it does make the cheapest decision within that time step, and we've got two permutations on that because it's when you have storage integrated into it, it's actually a relatively involved decision. In addition to the economic dispatch, we've also created a new dispatch in Homer Pro that we call fuel minimization. And that's where we say, no, the most important thing isn't necessarily economics, it's utilizing our renewables more and using less fuel. So there's a lot of tools in there that you can use for creating priorities and prioritizing the dispatch of your various components.
Great. Can the CHP, the Combined Heat and Power module, model natural gas microturbines and natural gas reciprocating engines?
Yes.
Yeah, we can model anything that turns fuel into power, basically.
How about wood?
If you can define the function of how much wood it takes to create how much power at different levels, we do use biomass as a fuel.
And if I can jump in here, one of the new features in Homer Pro is this ability of a minimum generator runtime. That's really useful for some of the steam-driven type systems where once you turn it on, you really need to leave it on for a period of time. We have that as an option now in the generator, so that gets us even closer to getting those spot on. It's a big improvement over Homer 2.
Great. How about a way to see ROI and payback in the results? You showed the cash flow.
Yeah, under the cost summary tab of the simulation results is a button that says compare. And you really have to, that's actually a comparison that you need between some kind of base case and your case. But yeah, we have that. It's maybe not as easy to find as you'd like, but if you go to the cost summary tab of the simulation results, you can see that.
And if you, I think we're going to post this video up online. If you go back and review it, that was one of the topics I covered as I went through the sort of quick introduction. So you can see a video demonstration of that if you like.
Okay. So if I want to derate a battery for temperature, do I have to do that manually? Do you have any derated data available for certain models?
Not yet. We're expanding our component library, and that's a great suggestion. But in the meantime, you can just create your own battery, changing whatever parameters you want.
Okay. Is it possible to add other costs like buildings, installation cost, wiring, and meters for distribution into your model?
Yeah. So we under the project button of the system ribbon, there is an option to add in system fixed capital cost and system fixed O&M cost. And that's a good spot to put those sort of costs that are less influenced by the design.
Great. Thanks. Is scaled wind speed scaled to hub height?
Go ahead, Peter.
So there's two different issues there. Well, what you're just talking about is what's often called wind shear, and that's handled on the wind resource page. There's a tab that says variations with height. So you can control your wind shear parameters, a couple of different functions for that, etc. So that is handled, but in a different place. The scaled parameter is simply to make it easier for you to, for example, use data from a nearby airport, but you think that's actually the wind is better or worse where you are than where the data is from, or to do a sensitivity analysis, which, given how important the wind resource is, we almost always recommend that you do a sensitivity analysis, so that scaling just makes it easier to do that sensitivity analysis. So there's two different things going on there.
Okay. Let's see. Okay, we're getting a couple related questions, so I'm going to try to combine them, but it has to do with tariff structures, tariff databases, state laws, different states, different countries. Peter, maybe you could address that.
Well, the Advanced Grid module has the ability to create fairly complicated tariff structures. We can have demand rates, we can have time of use rates, seasonal rates, various ways of handling net metering, etc. We don't have a database of tariffs because there's just too many of them. It would drive us nuts trying to keep that up to date. But you can put in, there's quite a bit of flexibility in the Advanced Grid module.
All right. And then the other one that comes up a lot is load growth and fuel and changing price, like grid prices over life of a project.
No, we don't do that. We can do sensitivity on those, so you can see how the results vary as the load grows or as the fuel prices change, etc. That's fairly. I don't know. We know people would like to do it. It's a fairly ambitious enhancement, so one of these days we'll have the resources to do that. We hope.
Right. Okay. All right. All right. So back to some of these.
I see a question about thermal loads.
Sure. Go ahead.
And we can handle thermal loads, and they can be met either with excess, waste heat from the generator, or excess renewables, or from a boiler. So that handles a lot of what people would want to know to model in terms of combined heat and power and using a thermal load controller as a way to stabilize a high penetration renewable system. So we can do a lot of what you probably are thinking about, maybe not everything you're thinking about, but we do have a capability to model thermal loads.
Thanks. Can the system prevent stupid results? I'm just reading the question, i.e. running genset only at 20% load?
So that one, yes, we prevent that. So we do an hour-by-hour dispatch, and one of the factors that you specify for a genset is the minimum load. And so, just to provide a little context to some people who might not be as familiar with this concept, diesel generators in particular don't like to be run for extended periods at low power outputs. They undergo a phenomenon called wet stacking, where you get condensate in the stack and it gets wet and it destroys the engine. So we've included this minimum load ratio so that when you're dispatching it, the generator only operates within the acceptable parameters as specified by you the designer.
Okay. Are solutions optimized on a time series basis or just on peak load? And I actually think you already showed how to drill down to daily results, hourlies, etc. But
yeah, so the system, the system will meet the reliability that you specify. It's both hour by hour and peak load.
John, I think that question, I'm guessing he's imagining a much, much simpler model that just designs a system to meet peak load, which we would argue would be a very bad way to design something. So it's really, really important, and one of the main purposes of HOMER is to do a chronological simulation for the entire year. I hope I'm understanding the question correctly.
Yeah, and just to add on, a lot of the other models that are done when comparing renewable energy technologies just look at a levelized cost of energy without consideration of the fact that the load has to be met in every time step throughout the year. So we not only meet the load, but we actually meet the reserve requirements so that we have uncertainty within each time step. So it's a robust analysis for ensuring that you design a system that meets the load requirements that you've specified.
Yeah, I'm going to just follow up with that, the question here. So I think this is a training question. Someone says they had issues with unmet load even though they were designing the system to cater for peak loads. So why would that? Why might that have happened?
I'd have to look at the file. What they mean by catering to meet peak loads. Was there a generator? Typically, if you have a generator bigger than the peak load, you won't have any unmet load. Now, there's always counter examples. If you're designing a system without a generator, sometimes it's pretty hard to avoid some unmet load, which is why we have a parameter that maximum allowable capacity shortage on the project page to allow a little bit of unmet load, which is hard to avoid in a system without a generator. That's a too specific a question to answer without seeing the file, actually.
All right, thanks. So I have a couple internationalization questions. I know some of these were answered in chat, but about how to make my own currency show up and other languages. So is HOMER going to be in any other, how can I? Yeah,
well, we're in the process of. It's not exact. I'm not sure where it's going to make it into the 3.2 release in April, but we are creating an internationalized version of HOMER and hope to have a French and Spanish version. We were hoping for April, probably won't make it into April's release, unfortunately. But most likely the next one, but we're working on that one actively.
Actually,
and then
we will release those when they're ready, Peter. Sorry.
Oh, okay.
Yeah.
Right.
Yeah.
Okay, great. But not sure exactly when that's going to be, unfortunately.
Right.
And on the currency issue, I think we've got that handled. John Auerbach, didn't you? Maybe can you jump in on that one?
Wait, sorry. Can you repeat that?
Can't HOMER Pro handle any currency that you've got set in Windows?
Yes, it can. So it'll adapt to whatever currency you have set in the Windows operating system, and beyond that, as long as you're consistent with the currency units in all the inputs in your model, you can use whatever currency you would like.
Okay. Another bunch of questions I'm getting relate to resource data and country. So people want to know, John Glassmeyer showed the resources button. Can you talk about what data are available and for where?
Right. So right now, the data that we have available in the software is for solar PV, and it's from two databases: an NREL data set, a National Renewable Energy Lab data set, and a NASA data set, depending on your location in the world. Excuse me.
And so there's data for everywhere in the world.
Yeah.
At least from the NASA database. So wherever you are, you can get solar data. Wind data is a lot trickier, but we're working on it.
But we're actually going to be integrating. John Auerbach may want to speak to this. I believe we're going to be integrating some additional resources to help with wind as well. But that'll be in a future.
That's right. Version 3.2, like I demonstrated, you can download the NASA surface wind data. There are issues if you're trying to be exact that probably Peter could talk to, but that data will be available for download into HOMER.
Right. Wind data is so much more site-specific than solar data. So the NASA data it'll give you the seasonal profile. It'll give you some kind of average over an area, but especially if there's any complex topography, mountains or ridges or anything, it varies over very short distances. So you'd still want to do a sensitivity analysis, and if you're on the verge of making a significant investment, you probably want to actually measure, put up an anemometer and measure it.
Right.
Small
I'm going to
project,
actually,
yeah.
sorry, go ahead, Peter. I was just going to say, I'm seeing a lot of the chat coming in, people talking about the accuracy of the data. So you can import your own data. So the data sets that we have available are what they are, and then if you have better data available, you can use those data.
And there's no question that the data from NASA is not meant to be super precise. The impact of that inaccuracy on solar is relatively minor, but on wind it's very significant.
Okay, we're just about done. Let's see, I'm just kind of looking down here, seeing what hasn't some of these questions really should probably be put in as support questions.
Yeah, sorry if we haven't gotten them all.
I see a lot of questions about new functionalities, and I just want to chime in that if there's a new functionality you want in Homer Pro, first, please tell us. And second, we're always looking for partners to help us develop the software a bit more. So if you're interested in getting a particular feature or component or something included in the software, we can work with you to help to develop that within the software, and we'd love to do that.
Okay, great. All right. Well, I think it's noon, and we could go on for a long time, but we have, you've got up in front of you where to get help, where to get training. The discussion group, that last link there, that's at our users group, so we really encourage you to join there and discuss and ask your questions and get your questions answered. So with that, I appreciate certainly all of our users who came today to listen, and to ask your questions, and also our presenters. So thank you all, and we will have this recorded. So it takes us a few days sometimes to edit it and get it up, but we'll have it, and you will get an email with that link, and you can share it with anybody you'd like to. So thank you.